Hello, everybody, and welcome to Dot to Dot. Well, today I'm going to explain and show you an incredible thing about Nolan's cross, how it's configured, how it's oriented, proportions, everything. And this discovery was made by Corian Mall last year from a site in England. And I'm going to take you there and show you how this site actually is the template to Nolan's cross. It's amazing. It's not speculation. It's pure fact in geometry. It's also going to give us an understanding about the Oak Island map and why Nolan's cross is extended out to the North Anchor and that the 432 extension exists from Cone D. So let's take off from Oak Island and go over to England to this ancient site. It's quite amazing. Stay tuned. So here we are at Temple Beeld. Now, Beeld is a word for a sheep enclosure, but I think this is far from a sheep enclosure. These standing stones have been here since the Bronze Age. And as you'll see, the walls were constructed, they say, several hundred years ago, but they are constructed in such a way that it is not a sheep enclosure. They form a geometric template, and we're going to look at this geometry from the wall alignment and especially this arc. This arc is very telling of the site's configuration. Okay, so let's get some orientation to the site. Now, one of the big stars that help us orient ourselves is the sun, the most reliable star we have for orientation. And this method of orientation goes back to the Egyptian times, maybe even earlier, Mesopotamia. But this way of orientation is very reliable. And with an accurate methodology, you can get your orientation very accurate. Uh, Also, the use of geometry, like Pythagoras' theorem, was used long before Pythagoras. And the knowledge of equilateral triangles to find the 60 degrees and bisect all the angles of orientation in the compass is also used. And they used rope or some kind of knotted material like rope to do their calculations and to get their orientation. And this is something that has been used for ages. Now that we have our compass full and the directions, we can now assign our axes, measure our axes, and we have the short axis going 60 to 240, and that is from the east to west. And we have the long axis, which goes from 150 to 330. And these are the same bearings that conform to the Nolan's cross, just like Corian Mall said. So let's move to the next step. Now, I did careful measurement on this site from Google Earth, and the long axis measures at 100 feet. And the axis from the east and west standing stones, which forms a chord across this precise arc that is built, is 60 feet. Now, this precise arc is telling of this site. Why would somebody build an arc like this so precisely for sheep? But this arc is a 50 foot radius that is anchored at the southern standing stone. And it is something that will be used in these calculations. So our calculation begins from the center stone, and we're going to find the distance from the center stone to the chord center. And we do this with the formula using the chord length and the arc of 50. And we're going to find that this is 10. So if we subtract 10 from 50, we get the remainder up to the south standing stone as 40. Now, this is important to realize that the half of the chord is 30, and now we have a 30-40 relationship. And therefore, we can set up a 3-4-5 triangle where we have 30, 40, and 50. Now, this is important because 3-4-5 triangles are used in surveying. The 3-4-5 triangle functions as a way of getting a straight line, and the straight line is dictated by three things. One is the maximum distance, which is 50 in here, because that is the length of the hypotenuse. The second is the 90 degrees. Now, the 90 degrees always goes on what we call the control axis. The control axis is what is lined up 90 degrees with the working axis. Now, the working axis is how we measure the line. This is the line that we're traveling on to get our straight line and to measure our distances. And in the case of a hypotenuse, the 5 is always measured through an arc where the 3 side and the 4 side are measured from corner to corner. Okay, we're going to be moving a little fast now. So if you need to pause to read some of the notes that I've written, it would be a good time after this to start. Now we're going to look at the proportional features of this axis, and we're going to take from the center of the chord a radius out to the south standing stone, which is 40. And we're going to mark it along the axis where it intersects. And we'll find that this is 30 below the center. Now, this is an important thing with Nolan's cross because what's left over is 20. And these proportions, you'll see, will match Nolan's cross. With these proportions, we now convert to base 12 from base 10 and multiply by 10. And we get the exact proportions in Nolan's cross. We also find that the arc, the importance of the arc and the arc height and the length of the arc, which matches the length of our proportioned line of Nolan's cross, which is 60, matches. Now, if we add the crossbar of Nolan's cross, which would be 50, we find that, it is equivalent to 720. However, this 50 is the hypotenuse of the triangle, and we're going to find that this is one of the things that clues us in, along with the 60, that this will be rotated 90 degrees. So if you notice, the crossbar in Nolan's cross is 50, and the axis, the 330-150 axis, is dedicated to 50. We're going to rotate that so that will become our control axis, and the 60 chord line will be divided in half, and the 60 to 40 axis will now become our working axis. So that now that we've switched our axis 90 degrees, this requires us now to use the sides that are 90 degrees of the hypotenuse, which is the 30 and 40 side. Now, since this 60 foot chord is divided in half, we know we're going to use the 30 side along the control axis, and we will take the center point where the center of origin, and we're going to go up to the chord length and measure an arc and mark those points, just like we did at the start to get our 30. And we're going to take those points and we're going to go from there. We're going to use the 40 side as our operative side, and we're going to go 90 degrees along the control axis, and we'll mark a point at the end of each of the operative triangles using the 40. Now, since we're using the 30-40 sides of the 3-4-5 triangle, this is why our rotation is forced 90 degrees. Also, notice that the diameter now is at the center, and we have a diameter of 1440 or 100. And this completes the full design. Now, when we add Nolan's cross, which is 50 or 720, we will add that bisected at the center origin. And this will divide our axis into 4 equal segments of 360, which also matches Nolan's cross design. So there we go. We have Nolan's cross aligned in the 60 to 40 direction, just like on Oak Island. And it is proportionally the same as Nolan's cross. And it is according to Brian Farrow's dimensions that he proposed a while back. We also have a conformance to the Oak Island map with the 1440 length to the north anchor from Cone E, and also the 720 distance to the south anchor at the 150 position. Well, I hope I've made it clear that Temple Beeld is a geometric generator of Nolan's cross, and that perhaps Nolan's cross was designed there at Temple Beeld and then that design taken over to Oak Island. It's all ancient geometry. Thanks for watching, and I'll talk to you later.